Hey, welcome. We're taking a look at some periodic trends today. And actually, right now, today, we're just going to roll out some of the definitions so we can work with them more after fall break. All right, so we are still in Unit 5.2. And again, we're going to look at some definitions today, some of the trends on the periodic table. We're going to look at some of the definitions that go with them. So starting off, the first thing, or one of the first things we'll discuss, is what we call the atomic radius. Now, when you think of the radius, talk about circles. Radius is from the center to the outside. There's our radius. So we're talking about the radius of an atom, talking about from the nucleus to the outermost valence shells. And this is the size of an atom. The atomic radius, the size of an atom. So keep that in mind as we work with atomic radius. We're talking about the size of the atom. Next up, we have ionic radius. Now, very similar to atomic radius, we're talking about the size, but this time we're going to be talking about the size of an ion that the atom forms. Now, there's actually going to be two different types of ions. So if you keep in mind, the first type of ion is like sodium. It would be an atom of sodium, and sodium is actually going to lose an electron and form a positive ion. We call it a cation. So one electron comes off, and it's this electron right here. Oops, I think I did too many shells. Sorry about that. I'm trying to not do that. Well, good. We'll have kind of an outline of where that third shell was. Okay, so our first shell was right here, and then our second shell is right here. So we have a full octet on sodium ion. So we get Na plus, that's sodium ion. We have our full octet, 8 electrons. And you notice he got smaller. So we call positively charged ions, ions that lose electrons, we call these cations. And cations get smaller. They have a decreased energy level. And you can see that here. We were out to the third energy level. We lost that electron. Now we only have 2 energy levels. Our valence energy is the second energy level instead of the third. And so obviously the cation, an ion formed when an electron loses, is lost. We have a positive charge. That is going to be a smaller ion. And then our other option is to gain an electron, to put an electron onto the atom. And these are known as anions. And it's going to form a negative charge fluoride ion. And again, he gets to his full octet. So he gets to all 8 electrons. by gaining an electron. And this is called an anion. So whereas our cations got smaller, so whenever we form a positive charged ion, it gets smaller than the atom. Our anions are actually going to get a little bit bigger. So again, anions are negatively charged ions, and they're going to get a little bit larger. And one of the big reasons for that is they now have more electrons, which need more space. They're negatively charged. They're going to kind of push away from one another. So more electrons makes it an anion and makes it just a little bit bigger. So kind of keep that in mind as we work through this unit. Our cations get smaller, they lose an energy level. Our anions get bigger, they're gaining more electrons. So two different things can happen there. All right, next up, we're going to look at ionization energy. And ionization energy is the amount of energy that's needed to remove an electron from an atom. So I'm going to take a look at aluminum. And actually, I'm going to take a look at several ionization energies. So here's aluminum. And an atom of aluminum has 3 electrons. This first one right here is going to come off pretty easily. It's not going to take a whole lot of energy. So not a very big starburst for that first one. And that leaves us with an aluminum +1. So I'll make that a little clearer. But, and here is the idea, aluminum is not yet done losing electrons. If you take a look, he still has a couple of electrons up there. He's trying to get to a full outer shell, a valence outer shell. So he's got 2 more to lose. So what happens when we take this next electron? Well, it's going to be a little more energy. A little bit bigger starburst. So here's our ionization energy 1. Here's our second ionization energy, the amount of energy to remove a second electron from aluminum. Now we have aluminum +2. But our aluminum +2 still isn't where it wants to be. Aluminum +2 still has 1 more electron to take or to give. And again, it'll be a bigger amount of energy than before, but not necessarily a huge amount of energy, that third ionization energy. So there's our starburst. Again, it's a good amount of energy. It's not an amazing amount of energy. Now we've got aluminum +3. Now we've got our full valence shell. Now aluminum is happy, if you will. He's got his full outer shell. He gave up this electron right here. Hooray, hooray, hooray. I'm actually going to turn the page here and look at the aluminum +3 we just had. if I wanted to remove one more electron, any of these 8 will do. Let's just pretend we're going to remove that one. And make aluminum +4. This is going to require a lot of energy. This 4th ionization energy for aluminum is going to be massive. Probably can't even draw a big enough starburst here. The amount of energy to remove that 4th electron is just outrageously huge because he's got that full valence shell. So removing this next electron, see these first amounts of energy, IE3, IE2, IE1, they weren't so bad. But to remove this one, man, we've got our full 8 electrons. There's no way he wants to get rid of that electron. It's going to be super hard to take it. It's going to take a lot of energy, a huge ionization energy. All right, so there's our ionization energies. And the 4th thing we're going to talk about, the 4th trend we're going to mention, is called electron affinity. Now, it's not infinity like a limitless number, it's affinity. Affinity in chemistry is a term we use to usually kind of mean love. Something really loves or really likes something. So electron affinity, how much an atom loves an electron. And the reason why we work with electron affinity is, remember, there's 2 ways to make an ion. One way would be to remove an electron, and that's ionization energy. And then the other one is how much an electron wants to gain an electron, because you can also gain an electron. So you see that here, we're gaining an electron. We're measuring the affinity that this atom has for that electron, the love that this atom has for the electron. So if I were to have these 2 atoms and I throw an electron down in between them, which one wants that electron more? That is electron affinity. And hopefully you guys are recognizing fluorine is going to really go after that electron. Look, if he gains 1 electron, he has a full octet. He really, really wants that electron. Lithium, a little bit. I mean, he'll get a full 2s shell if he gains the electron, but really, he has a very small love for that electron. So this guy's going to get him. He's got a much larger electron affinity. Fluorine does. Much bigger heart is my way of showing that. This guy's just a little heart. He kind of wants him. He wouldn't mind filling up that 2s, but no, it's fluorine's going to get that electron. If I throw that in between them, fluorine's going to get it. All right. So there are the 4 trends. Again, we're going to work with these when we get back from break. So get them down, take a look, and watch these terms. You see these terms quite a bit. I think I introduced about 6 of them here today. So make sure you're taking a look at them and know them for the test. All right. Well, we'll see you next time.